Hello, kids. Today we're going to talk about isosceles triangle. I usually say isosceles because you have on two eyes and both your eyes are the same. So let's figure it out. So you need a compass and pencil and maybe marker in a little ruler. So I will start with drawing a line, and I would like for my one side to be 5 centimeters. So I'm gonna take and measure how big is 5 centimeters. I will not need extra, so I'm gonna do that, erase, and I'm taking my points to the end. So this would be two of my points of this line segment, and that is going to be a 5 centimeters, and I can mark centimeters if I would like you. So this line segment would be maybe E segment, and you can make E like a small lower letter equals 5 centimeters. cm stands for centimeters. I can label this could be E, and I will need a third point of my isosceles triangle. So I would like that to be 7 centimeters. So I'm going to open up my compass and I'm going to measure how big is the 7 centimeters. So it's about like this. And then I can do my arcs. I can do from point E and then I will do from point, let's do E, F, G. This would be G. Okay. And I'm going to do the 7 centimeters as well. So when I make a little arc above the middle of my first line segment, then I can make two arcs. I can do it one more time if I'm not sure. And there will be intersection of these two arcs, and that would be my point F. My point. All I need now is to add connect the line segment. So point EF will give me that segment, and EF will be an I have isosceles triangle. We can check that I did good measurement. This should be a 7 centimeters, and it's about like that. I can see 7 here, and I can label the exactly 7 centimeters. So I can say that, and also this side is a 7 centimeters. So I create a triangle with the two sides equivalent or same. So I can call this like maybe F, lowercase letter, 7 centimeters. And I can do this one, G is equals to 7 centimeters. The lowercase letter is for the line segment to label those, and the points are usually uppercase letter when you do that. So now I can label this triangle as a little symbol for a triangle, and I can say E has to go in clockwise. So E, F, G, triangle EFG. I also can see that line segment EG, and line segment is a line above letters, and it does not have arrows, just a line, a little line, is same as 5 centimeters. And then I can see that line segment EF, line segment, is congruent to line segment FG. And that those both are equal to 7 centimeters. Okay. I can then explore my angles. So if I look at angle E, angle that surrounds point E, I can highlight that angle. If I want to, I can show you that angle lives in a circle if I make a circle around point E. So if I do that, you can see that my angle lives right in a circle around point E. And this is less than 90 degrees angle, because if it's 90 degrees, I usually use a paper so I can show you this is right angle. So if I put my paper there, my angle should be 90 degrees. This line should be right here, but it's much less. So it's not 90 degrees. My angle is less. I can label my angle by doing this little arc in arrows. This shows me that I can measure angle from point EF, the segment over here, or I can measure my angle from EG to EF. Either way I measure, the measurements will be the same. And then I also can do the label G, and I will measure that angle. So I have these. Okay. To measure angle, I know they're going to be less than 90 degrees, but then I can use my protractor and I can measure it. I can put my line on my center circle E, point E, make parallel to the line segment EG, and look for the line that it says 0. So this is my line 0, and if I go and measure it, this, I can go 10, 20, 30, 40, 50, 60. I will have 65 and 65, 66, 67, 68, 69 degrees is about. My angle is about 69 degrees. Okay, angle around point E. Now, angle about point G should be the same, but we have to prove it because two sides the same, two angles are the same. So these two adjacent angles. So, and we can see that if I put the 0 right there, it's going to be exactly outside 0, 10, 20, 30, 40, 50, 60, in 65, 66, 67, 68, 69 degrees. So it's about 69 degrees. When I know these two angles, I can add them up. So if I say 69 degrees and a 69 degrees, that will give me 9 and 9 is 18. 1/10 will carry on. That would be 138 degrees are these two angles. So to find the third one, I can measure it, or I can think what angle at 238 will give me 160 degrees. That's one of the thinking. Or Or I can do 180 degrees minus 138 degrees will give me that third angle that is missing. So either way I do, I can think this way. I can think, okay, 8 and what will make 0 because I need here to be 180. So I can say, oh, 8 and 2 will make 10. So it's 10. I'll remember a 1. So 1 and 3 is 4. And then plus what? Oh, sorry, I messed up. I don't, what did I do? 4 and that would be 6. Oh no, I mess. I'm sorry. Gets carry on. So 130. That's 3 and 1 is 4, and then 4 and 4 makes 8, and that would be a 42 degrees. So this one has to be 42 degrees. And then if I take 180 minus 38 is going to give me also 42 degrees. I can subtract. I cannot say give you 8 and I have 0. So I have to regroup to tens, have 7 tens left, and 1 10 will give me 10 ones. And I can say 10 if I did subtract 8, I will have 2 left. And 7 minus 3 is equals to 4, and 100 minus 100 is, so that is 42 degrees. So I figured it out that this angle has to be a 42 degrees. And I can say then all three are acute angles. They're less than 90 degrees. This would be 90 degrees, but this one is less. So this isosceles triangle can be also called acute triangle or acute. And that is when we classified, triangles by sides, we can say that is isosceles triangle because it has two sides the same, this one and this one. And then if we classify by angles, this is acute triangle because all three angles are less than 90 degrees. They're all acute angles. Acute angle. Okay. We also can, so we can label angles like angle E is equal to 60, is congruent, let's do that, congruent to angle G, and both are equal to 69 degrees. And then angle F is equals to 42 degrees. Okay, we can also say that angle E plus angle G plus angle F is equals to 180 degrees. That's another way of thinking of it. Okay, so then we can explore rotation, line of symmetry, and symmetry is where I can draw a line that the parts of the shape will be the same. I will say like congruent halves. So I can see right there, then I can draw the line through, and I will have two equivalent shapes. I can do better job if I put my ruler to be parallel on a line segment and then drew the dashes through, and that will be my line of symmetry, one line of symmetry. So we can prove that line of symmetry if we create a triangle that is isosceles. I made that before. It's a isosceles triangle. And so if I fold it into two pieces through the line of symmetry, I will exactly have a two without any overlapping. I will have half of that triangle right there. So here is the, and then other side is, so the line symmetry cuts the shape in half in equivalent parts. And then this one has only one line of symmetry. If I drew those little dashes, usually we drew the dashes when it's line of symmetry that will, and if I try to like do the here cut in half, you see it does not overlap. It's extra here, and then they're not they're not same. So like when I do this way, you don't have overlaps in the parts are exactly the same. So we can conclude that isosceles triangle has one line of symmetry. Okay, and we can explore rotational symmetry by using the paper, butcher paper, for like the see-through paper. I don't know how you call it. And we can do that if we put the dot above the point that we're going to rotate, like that. And then if it stops and fits in the shape on a way of rotation, then it will have a rotation. If it doesn't, then it has a zero rotational symmetry. So we can go in slightly rotate and it doesn't match. Okay, it does not match. Again, all the way. We can rotate further. And we can conclude that this shape does not have rotational symmetry. It's a zero rotational symmetry because it doesn't stop at the shape. So it has zero rotational symmetry. Okay. So thank you for listening. I hope you enjoy, and thanks for being with me. Love you. Bye.